Okay, well, it wasn't my fault this time actually. People are being weird, so you can't blame me for there being three parts to this video when there could have just been one, and I'm too lazy to edit, so they'll probably show up as three. So anyways, I was saying high humidity, the exact opposite process. There's relatively high moisture in the atmosphere, and this is transferred through gas exchanges on the bladed grass. Which makes them more resistant to fire, obviously, because water, fire, douse, yay. So anyways, that was actually my last sketch. No more sketches actually. So yeah, that's why it's more difficult for fire to spread in a general high humidity sense. And wind, don't even talk about. Wind is just terrible in general because again, uh, first of all, wind consists of complicated fluid dynamics to examine. It makes the situation unpredictable. Wind influences the speed at which the fire spreads. The speed, the range, the direction, even the intensity at which because the wind provides even more oxygen in the combustion cycle. So what did we learn here overall? Anything that changes unpredictably, whether it be temperature, humidity, spread of the fire, or wind, are just terrible because that's less knowledge of the intensity and the spread of the wind for scientists and firefighters. That's less knowledge we have. It's less information we will have on how the fire will behave and how we can fight it, how we can accurately cut off the fire and contain it. Particularly changes in winds are absolutely terrible because, I mean, it's just one of the most dangerous influences on the behavior of fires. I believe I read this a while ago, but most of the people, I'm not sure enough to put a percent on this, but I'll just say most of the people who die in these wildfires are ones who get caught when there's a wind exchange or right after it. I won't get into wind exchanges, fluid dynamics, complicated math, but a lot of this math is uncertain too, so scientists can't do much about it. This is because in a wind change, what at first appears to be the side of a fire can quickly change to a larger fire front and is heading right towards you, whereas it was spreading away from you just a few seconds ago. That's just scary. Fires can move pretty fast, 6 to 14 miles per hour on average. Factor in the problem of the efficiency and of the embers in the wind, how efficient they are traveling in the wind and starting new fires by picking up and spreading to a new region, and you have something that's incredibly difficult to contain. And I haven't even touched actually on the cloud development, different types of fronts, how clouds are formed when there's surface heating, or how different pressures and temperature systems relate to the spread of fire in more detail. I'm just telling you that there's a lot of things, right? All of these things just take away information and certainty and complicate things. Combine all that with the fact that as each hour goes on, each minute of the day goes on, there are small changes in the weather temperature rises and fall with the cycle, as does humidity and winds, pressure fronts, etc. This means